Welcome to the presentation of the file hierarchy system, which is in Linux. To start the topic, what I did is I did a list of my root directory, and these are the items that I got. It's got these directories like bin, boot, dev, etc, home, lib, lib64, and so on. The next slide has a diagram of the common F file hierarchy standard tree. This is what it looks like. You have got bin, boot, dev, etc, home, lib, and so on. And all of these are inside the /root directory. Just a single slash is the name of the root directory. And sometimes when people are learning Unix and Linux, they don't actually are able to see the tree, and they just accept the word tree. So you will see images in courses like this one that I showed you before, and this one, and this one. Now if you can't see the tree, what I'll do is the ICT people and the computer science people, they call this a tree. So what I'll do is I'll turn the diagram upside down so it's easier to see what they mean by a tree. Now you can see that the root directory is below and the other subdirectories are above it. And the slash is the root. This is how it relates to the tree. When the subdirectories are presented in a different way, they look like the leaves of a tree, and the root is represented by the slash. Now we shall start with what is in each directory and explain what is in it. The first one is, we'll just take the bin directory. Bin is the short form for binary, and it's got programs which, when programs are made, they're written in a high-level language, which humans can understand. Examples are like PHP, C, Pascal, C++, Python, and there are hundreds more. These languages are compiled into a binary form which the CPU can run. The technical term for the CPU being able to run it is called execute. In some systems you will see the word executable files, and the short form is exe files. In Linux and Unix they are called binary files, and bin is used for the short name of the directory. Some people might call them bin files too. So the bin directory, which is /bin, contains the commonly used files related to the operating. For example, one example is ls, which is like dir in DOS. It's for listing files. And cp is the short form for copy, like in DOS, if you have a DOS background. Technically, not all files are actually binary files. They can be scripts. So they can be written in a high-level language which is interpreted when they are executed. They are called batch files in some systems, and in Linux and Unix they are called scripts. The scripts can be written in languages like Shell, Python, Bash. There's these strange names for these directories. There's also this point of having scripts and binary files inside the directory also applies to /bin, sbin, user bin, and user sbin. Even though the word bin is inside these directories, not 100% of the files are binary files. Now we go to the next directory, which is the /boot directory. There is a system which starts a motherboard, which is on the motherboard itself. It's called the BIOS, and this stands for Basic Input Output System, which is BIOS. And in some cases, some older BIOS systems, they need the starting of the operating system to be near the starting of the hard disk, which is sector 0. So in some cases, the operating system has to actually make sure that the starting files are located there. That is why the /boot directory was created. It's actually a separate partition which has to be located near the beginning of the hard disk, and the /boot directory is where actually located there. But newer systems, the /boot directory is in the same partition as the / directory. Doesn't have to be separate and does not have to be at the beginning of the hard disk. But there's just a technical issue from old systems. But it's just to know why you have a separate boot directory and what it is for. Whether your system needs it or not, the kernel will be found there. that's the executable copy of the kernel, and the starting files of the main operating system. The kernel is basically the name of the core part of the operating system which manages all of the hardware. Next, we shall be talking about the dev directory, which is /dev. All of the devices in Linux have a file associated with them. On all of these device files are located in the dev directory. If you read or write to a file in this directory, you shall actually be communicating with the device. For example, if you give cat/dev/audio as a command and you use this greater than sign, that means put the whatever comes out of reading that dev audio file into /tmp/file.audio. There's another directory called temp which you can use for making files. This is a temporary directory. So you shall be actually reading dev audio, and whatever comes out of the file goes into this file in the tmp directory named file.audio. What will happen is, since you're reading the dev audio file, the mic shall be turned on and you will be actually recording audio into the file called file.audio. And if this command will continue as long as you keep it running until you press Ctrl+C, then the recording will stop and the file size of file.audio will stop increasing. Then to see what has happened, you can say, okay, whatever is inside file.audio, which is located in the /tmp directory, you say cat/temp/file.audio, and you say put that into dev audio. Now you're writing to the dev audio device. Now what will happen is you can hear what was recorded from the speakers. So this is an example of reading and writing files which actually activates different devices. Now we go to the etc directory. The /etc directory, etc is the English term for etc. But this used to have a lot of other stuff before. But in Linux and the file hierarchy standard, it actually stands and represents all of the configuration files. So almost all of the programs that are installed inside the Linux machine, they shall have their configuration files inside the etc directory or some subdirectory inside the etc directory. This way, if an administrator wants to back up the configuration of all of the softwares, he just has to back up the etc directory. And to restore the system, we just have to install all the software from the CD and the internet and just restore the etc directory, and all of the programs, when they start, they shall actually read their respective files and get back to what they were doing before. Now, some softwares, if they don't have extra data files or do not use a database, then, like for example, proxy servers, DHCP servers, or routers, they shall work perfectly. And that way, the administrator can back up a whole system in just a few megabytes. For other applications which have a database or they are using other files in other places in their other respective directories, they need to be backed up. But the important point and reason for having the system and this separation of configurations and data and programs is that the administrator can avoid having to copy all of the programs in all of the bin directories. I mean, he does not have to, or he or she does not have to copy any of the binary directories at all, and they can be installed from the CD or the internet. The next one is the home directory, and we shall continue this. This was just a demonstration to check the audio quality in the presentation format, so we'll be continuing this later. Thank you for listening.